Capability analysis allows the user up to 50 entries per part location measurement, or a total of 150 entries. You can see we can go from 1 down to 50. We have 1, 2, and 3, thus the 150. Part measurements are for one part each, meaning you can make up to 3 measurements for each part. The white or clear cells, along with the 2 orange cells down under Sigma here, are not locked, but the gray cells are locked and password protected. I must caution not to copy and paste from another spreadsheet that has been locked. This will make the unprotected cells protected and render the sheet useless for additional input. The first choice at the top left side of the sheet is adjusted for estimated sigma divisible factor. This allows a user to use a factor other than 1 relative to estimated sigma or standard deviation. I must mention that the adjusted estimated sigma has a default divisible factor of 1.128, meaning the average is divided by 1.128. This is a function I have copied from my conversations many years ago with the owner of SPC for Excel. I never discussed with him why, but have left it in my calculations. I have given an opportunity for the user to adjust this factor for whatever reason. I have seen users go as high as 1.3. So when this is purchased, all these are cleared and zeroed with the exception of this factor being 1.128. You merely have to click in it, change it to whatever number you want, such as, for example, 1, and it will change the factors coming off of the adjusted estimated sigma over here. And we can go back to the 1.128 as I indicated we would keep. This is a function I've copied, located next to the adjusted sigma is the box for choosing the size constant. This allows the user to minimize input. For example, if the part is 2.499 and all the parts will start with a minimum of 2.499, then the user only need to input the number 16, 20, as you can see here, for example, and the divisible factor will show under measurement divided by a factor of number of 0.00016, where the 16 or the 20 have been divided by 1 million. That said, the actual number will be entered as the measurement average up to 3 measurements for a particular area of the part. In this case, we have 2, and that measurement average comes out to 18, which is where you see the measurement divisible factor showing 0.00018 or added to the 2.49918. The potential measurements are part measurement 1, part measurement 2, and part measurement 3. It is critical that the number is entered in part measurement 1 for any calculation to be completed. The 0 numbers have been hidden, even though we're going all the way through number 50. And in these formulations, I've added array formulas to not add the 0 cells into the calculations. The next cells are located at the top of the page and are as follows. Total measurement, which will be between 1 and 3. Part measurement 1 if needed, part measurement 2, and if needed, part measurement 3. If you have input part measurements in 2 columns, then you'll enter 2. As you see, we have 1, part 2, 2. The next input will be count per measurement, and in this example it was 29, so you put 29. If you have input, that measurement would enter 29, so we'll change that to 29. And as you can see, The column 29 is sample count will be 2 times 29, which equals 58. And will be calculated and appear as sample count, which is locked. And this number will also be entered over in statistics under count. The next to be entered is the upper limit, USL, and the lower limit, LSL, along with the mean. Once these have all been completed, all the capability analysis statistics should show up in the column to the right labeled statistics. The chart located in the center has been set for a project I just finished, and if you need to make changes, I've copied it to a sheet named chart. It will take some time and some skill to make those changes, and it is too involved for me to try to put into an audio at this time. To the far right of the statistics, I have given written description of each statistic such as Sigma, PPL, CPK, etc. as a reference in case some persons would like some more information as to the meaning of the terms. And also, the objective of this type of process evaluation is to reduce the number of bad parts. I have input a Sigma calculator located below the chart for determining the defects per million opportunities, or DPMO, along with the calculated percent per million and the CPK and Sigma. You can enter the Sigma number, such as, say, 6, which would be ideal, and it will show you the CPK, which in this case would be 2, that the DPMO, meaning the defects per million opportunities, would be 3.4, and the percent of scrap would be like nothing, 99.97. For example, if we wanted to put in a standard 1.33 CPK, I will enter that under CPK, and as you can see, that will calculate out to 3.99 sigma, and you end up with 6,387.2 parts per million, and what percentage that would equal. I have set the print for landscape and included all the data less the description on the far right. I would suggest saving as a PDF file, then you can eliminate all the data and start over again. And if you have any questions, again, please get in touch with myself, Dale Savington, under the input part of the www.admart.com website.